basic concept. I'll give you few elementary question from class 11, right? Very elementary question. You do it and WhatsApp me, right? So let me check that how much you are able to do it, right? So first question is from class 11, that identify the nucleophiles. First is NH3, second is water, third is NH2 minus, fourth is OH minus. You solve it and WhatsApp me. Okay, so now I'm explaining to you. Now tell me, what is nucleophile?
Proton loving elements.
Pardon?
Proton loving elements. Compounds.
Proton loving, right? Okay. Or nucleus loving.
Yes, sir.
Nucleophile. If you analyze this word, it means that nucleus loving. And you are right in saying, because nucleus has proton, so you can say proton loving also, right? Nucleus loving. Nucleus has proton, and proton has positive charge. So you can say that those who love positive charge, it means that it must be electron rich.
Yes.
So we will always talk in terms of electron now onward. Okay, this is for first time analysis, how we understand the word nucleophile. But once we have understood the word nucleophile, we are going to define this as electron rich species will be nucleophile, right?
Yes.
Now, in last class, I told you draw the structure with common bonding pattern. So for entire class 12, and if you happen to study chemistry further, nucleophile is electron rich species. Now draw the structure. That's why we need common bonding pattern. So if you draw the structure of NH3, how many bond and lone pair nitrogen will have in NH3? Nitrogen.
3 bonds and 1 lone.
1 bond lone pair. So 3 bond and 1 lone pair. Do you see electron there?
No, sir.
No, nitrogen is a lone pair, na?
Yes.
It means electron rich is this. Water. Oxygen will have how many bond and how many lone pair? In water.
2 lone pair and 2 bonds.
Very good. Do you think it has got lone pair of electron or not?
Yes, sir.
It is also nucleophile.
Yes.
NH2. How many bond and how many lone pair do you have?
2 bonds and 2.
2 bonds and 2 lone pair. Nucleophile,
Yes.
right? And OH minus. How many bonds and lone pair do you have?
2, 1 bond and 3.
But never think in terms of charge. I'm going to explain why we put charge. Then you will realize कि इतना बेसिक था आपने क्लास 11 में नहीं सीखा. Charge वो नहीं होता जो आप सोचते हो. It's not that what you think. It is basically formal charge. If you remember, there is a formula in chemical bonding of class 11 NCERT. Formal charge. That is formal charge. But I'll tell you a simple way to find out the formal charge. Right? You
Yes.
don't have to use that formula. Simple technique. Anyway, all are nucleophile because every species has lone pair of electron. That's why they are nucleophile. Right? Answer is all. Now you realized what should be the correct answer?
All.
Okay, the answer is all because all are electron based. All have got lone pair of electron. Now, before we move ahead, let us clear our concept about the charge. From where charge is coming? Why you put negative charge? Why you put negative charge? Positive charge, right? To understand this. And you know what your answer was based on the premise that it has got negative charge. Negative charge, that's why they are nucleophile. Huh? So you never thought about the neutral species. That could also be a nucleophile. Fine.
Yes.
Now, charge. Let us talk about charge. Understand this. But whatever I am explaining to you, keep in mind, you should have clear understanding of the structure. How many bond and lone pair item has got in the structure. Otherwise, you can't take the fast decision, which I am trying to explain to you. Right?
Yes.
Now, second point is that what is the fundamental cause of charge? It is the electron excess or deficiency that gives rise to charge, right? So if you have excess electron, you have negative charge, and if you have less electron, you have positive charge. Simple.
Yes.
Now the question is, what is your reference point? Excess with respect to whom?
Equal charges.
No. For example, suppose you are talking about oxygen. Excess means that when it is alone, it has 6 electrons. Now, it will try to complete its octet. We know oxygen will always try to complete its octet.
Yes.
But suppose if it says that how many electron is owned by me in a compound, and suppose it finds that I have 7 electrons, means it has gained 1 electron, it will have negative charge. If it feels that it has only 6 electrons, it will have 0 charge. Because 6 is the number of electron when it is alone, and after the formation of bond also it has 6 electrons. Then it has no charge. And suppose it has 5 electrons, it is number of electrons. Then it will have positive charge. And these are the number of electrons own electron in a compound. Own electron is different from total electron. Which is always equal to 8. Mostly in compound. Because it always wants to complete octet. Note down, then I'll explain what I'm saying. You don't have to remember any formula. First understand, and if you understand the basic, you'll find it's very easy.
Yes, sir.
Then
Yes, sir.
now understand what. Let us understand with this type of example. See, in last class we discussed that whenever oxygen will form a compound, it will complete its octet. Then
Yes, sir.
when it is going to complete its octet, then why I'm talking about one electron, I'll explain you. Suppose you share A and B are sharing. Now tell me how many electrons A has got. Total electron. Total electron of A. Tell me 2, 4, 6, and 8. 4 plus 4, 8. Agree?
Yes, sir.
But if I say one electron of A, one electron of A means imagine that partnership has broken. Now tell me, what is the number of one electron of A?
6 and
6. Tell me, what is the total electron of B? Total means you consider this bond also, 2 bond. Total means if you say that 2 plus 2, 4 plus 2, 6 electron I've got. Agree? So, agree or not? You're not audible.
six and
Okay, now it's okay.
yes, sir.
Now tell me if B says what is the total electron it has got?
4 electrons.
2, 4, 5, 6. Total electron 6.
Yes, sir. Total electrons
6. But one electron?
4.
Oh, you got that one. Because when you think about separation, half the electron of sharing you will get, and remaining half will go to other shared electron. Right?
Yes, sir.
Note down. Now we are going to draw the structure of ozone. O3. Now tell me what is the charge over ozone? What is the charge over ozone? No charge.
Yes,
Okay.
yes,
Now
sir.
tell me what is the demand of ozone? What is the
6 electrons.
24. 24 it would like to have. Demand is right, right. You are right. It's a dream is to have 24 electron, agree?
Yes, sir.
And ability is 18 electron. Gap is 4. Sorry, 6. How many bond it will have? 3 bond. Agree?
Yes, sir.
Now draw the structure and WhatsApp me. Three bond. You just calculated 3 bond. Then you have drawn only 2 bond. How come? Should have 3 bond. Just correct structure and send again. Then center oxygen is how many electron? Count. It cannot have more than 8 electron. Every oxygen should have only 8 electron. Now again correct it and send the photo. Good. Now it's correct. Oxygen, oxygen, oxygen. 3 bond. First draw the bond. 1, 2, 3. Says center oxygen has 6 electron. 2, 4, 6. You need 1 pair here. Terminal element 2, 4 electron. 4 here. This has 2 electron. So 6 electron. Right?
Yes, sir.
Now tell me, what is the charge? I repeat, 0. Now find with respect to neutral atom, what is the one electron of oxygen? One electron of each oxygen. Tell me about this. Oxygen number 1, 2, and 3. What is the total electron? One electron. Total electron is 8, 8, and 8 because their purpose of making bond is to complete is octet. They have done it. But if they try to find out how many electron is owned by them, that you calculate this. Tell me. What?
One has 4 electrons.
One, see my hand. 1, 2, 3, 4, and 5, 6. Half of the said electron also you have.
Yes, sir.
So do you think it has got any extra electron? No.
Hmm.
It will have zero charge. Now tell me second atom. Second.
Also 6 electrons.
How come? Calculate it.
5.
So what happened with respect to neutral status? It has lost the electron or it has gained the electron?
Lost one.
Lost the positive charge. Total electron is 8. See this beauty here. 2, 4, 6, 8. But owned electron is 5. And what about this terminal oxygen?
7.
Huh?
7 electrons.
7. So what charge it will have?
Negative.
Sum all the charge. -1 + 1, 0. 0. So when you write O3, no charge here means zero charge. It is sum of all formal charge. And these are the formal charge. This question once came in entrance. Oh, what is X, Y, Z? You understood this point? So it is the sum of formal charge. So if you write 0 here, if you don't write any charge over O3, it doesn't mean it has no charge. It simply means if you're not writing any charge, sum of all the charge is 0. You got the point? And this, what we calculated, 0, +1 and -1, these are the formal charge. These are formal charge. You don't need to remember any formula. You understand? So here X, Y, Z are formal charge here. Hope it's clear to you? Now tell me, have you noted? Suppose I give you another difficult question from a J. If you look at this ion, what is the charge here?
Negative.
-1. So what would be your thinking in the beginning? That it has gained 1 electron. No. Sum of all the formal charge. See, there are 3 nitrogen. When you sum all the formal charge, it will come -1. Got the point? Now draw the structure and just write formal charge over each nitrogen. Draw the structure.
Sir, it's
Please send.
is it -4?
Pardon?
The answer is coming as -4.
Sum of all the charge has to be -1 because -1 is here.
No, -4.
Minus?
4.
I could not get your point.
Sir, I'll send.
Just send me the solution first. Or your audio quality is also slightly, you have to look into. Okay, you have done the structure correctly, but you have to write the charge. Number of bond is 4, so you have to write the charge. This is your structure. The structure is correct. Now you have learned the structure. Now tell me one electron. See, nitrogen, when it is alone, it has 5 electrons. Now tell me nitrogen number 1, nitrogen number 2, nitrogen number 3. What should be the charge over nitrogen number 1? See,
-3.
Huh?
-3.
How come? Half electron. When
Minus.
the charge line, you don't count that shared electron. You count half shared electron is your own electron. Suppose, understand this. Let us make it simple. Suppose you and your friend starts a business and when investment is 10 lakh. It means that although shared capital is 10 lakh, but half is your friends. So it means 5 lakh each is your own capital. Now tell me, what should the charge of nitrogen 1?
-1.
-1. What about this nitrogen?
0.
How come 0? Count this.
+1.
What is the charge over here?
-1.
-1. What is the total charge?
-1.
Minus. So this is sum of all the formal charge. You understood?
Yes, sir.
So in last class, what we did like this. We just drew the structure. We didn't calculate the exact charge, just like this. You can write structure like this or this. When you write charge over in close bracket, means you are not interested in calculating exact charge over each nitrogen. You are just writing the sum of all charge. But when you write charge over each nitrogen, it simply means that you are also interested in finding where you have extra electron. Got the difference? Both are correct structure, but this is a precise structure. And this you need when you draw the ready structure. That's why you will always have problem with resonance. You might not have understood clearly why this electron is going and why this charge is coming in class 11. Because this concept was not clear there. And you will find in every chapter you have application of resonance. In class 12, in every chapter you have to draw resonance. Okay, and put the charge. So that is the fundamental of resonance. Hopefully now you got the point.
Yes, sir.
Now similarly, suppose you say CO3 -2. What does it mean? Why -2 charge? Sum of all the formal charge would be -2. You draw the structure and draw the structure of CO3 -2 and find formal charge of all the atoms. Then we'll move to again nucleophile point and find formal charge of each atom. And WhatsApp to me. Write like this. Your structure is correct. Write like this. And don't write number. You should have everything is correct for you. Only presentation is. So you have correctly drawn the structure. Write just charge over there. And if you are using 1, 2, 3, 4, now it is confusing. Just write charge here. What is charge here? What is charge here? What is charge here? What is charge here? You will find charge will be -2. Sum of all the charge would be -2.
Yes, sir. Yes, sir.
Again, send the picture. Right. I understood why you put -2 charge.
Yes, sir.
So there are two ways to deal with the situation. Understand? First is you can put like this. In last class we did. It simply means that we are not bothered about what is the charge over each atom. But when you write like this, so you have to write like that will also do. Now once you understood this point, you can leave the electron. In book you find like this. Now you can explain that suppose I want to work, how many lone pair I will give to this oxygen? Tell me now.
How many?
How many lone pair? This oxygen where I put my finger.
3 lone pair.
3 lone pair. This.
3 lone.
Same. This.
2.
This.
No, no.
0. Now understood. They leave in the book you're writing, but they actually what happens? Sometimes you need that lone pair. Sometimes you don't need that lone pair. Until unless you are not clear how many lone pair and why they have charged, why you are writing that, right? So in organic chemistry, we always not write. Suppose I have written this structure. Now I'll come to. No, I have not put the lone pair. But you should have idea how many lone pair it will have. Not tell me how many lone pair it will have.
2.
And if I write this structure, now tell me how many lone pair it will have.
1. No.
O negative is 1 sigma bond and
2.
oh, bonding pattern. Go for bonding pattern.
3, 5. 3, 5.
3 in our last class. So here we'll have 2 bond and 2 lone pair. Suppose you want to draw it. If you need it, sometimes you will need it, then you can draw it. Sometimes you don't need it, leave it. But before you start leaving, you should have clear that what is the hidden number of electron.
Yes.
I think you are clear now.
Yes.
Now I'll go to nucleophile once again. Now let me sum up the entire discussion. The charge is sum of all the formal charge. And you don't have to remember any formula for formal charge, which we learned in class 11. Right?
Yes.
Okay. Now nucleophile is electron species, and there are 2 types of nucleophile. Nucleophile are electron-rich species, and there are 2 types of nucleophile. Neutral, negatively charged. Your perception was that only negatively charged nucleophile could be Now I'll explain you which I've just drawn a distorted version of periodic table. Here we have group 14 carbon, group 15 nitrogen phosphorus, group 16 oxygen sulfur, group 17 fluorine, chlorine, bromine and iodine. The element which I have written here and hydrogen here. Group 15 and 16 are nucleophile in neutral state also. Group 15 and 16 elements are nucleophile in neutral state also. Example, NS3, ES3, these are from group 15 element compound, group 16, H2O, H2S, C2H5OH. Note down, please. You don't have to remember all these things. Just draw the structure you will have. Say group 15, nitrogen. If you 5, immediately tell me how many bond and lone pair it will have. 3 bond, 1 lone pair. Just draw, and you know it is a nucleophile, electron rich. PS3, again of the same group, so same number of valence electron. H2O, 2 lone pair, 2 bond. See, very soon you will be drawing with the speed I am drawing. Because just what I just did the mental calculation. Oxygen 6, 2 bond, 2 lone pair, 2 plus 2, 4. Right? And since oxygen and sulfur are from the same group, so I didn't do the calculation. But negatively charged, it could be group 14, CS3 minus, group 15, NH2 minus, group 16, OH minus, CS3O minus, HS minus, group 17, chlorine, bromine, iodine. When negatively charged, all could be nucleophile. So those very simple. So this is you don't need to remember because negative charge automatically says that it has extra electron. But this you have to remember when it is neutral. So 14 and 17 are not fit for being a nucleophile when it is in neutral state. But 15 and 16 are very good nucleophile when it is in neutral state. But let me tell you, in last class I told you, whatever I am teaching you, I am teaching with some limitation if and buts, right? So those if and buts I am not explaining to you. I'm just picking the basic part and trying to explain. When you start learning more, you'll always find there is some exception, right? And some difference. Note down and then we'll move ahead. Then I'll tell you electrophile, because always nucleophile and electrophile react in all chemical reactions.
Yes, sir.
Right. Now, opposite to nucleophile is electrophile. Electrophile means electron loving. It means that they are electron deficient species. Very simple to identify.
Yes.
So always use the bonding pattern basics to draw the structure fast, right? So electrophile. Electron loving means electron deficient. Those who are deficient, that will love. Now, first thing is it could be neutral also. Don't think that always positively charged species would be an electrophile, right? So in the beginning, teacher says in your class 11 that if it has positive charge, then it would be electrophile. Not necessarily. Even positively charged species are not an electrophile. So we have to understand the rule because in class 12 we have to frequently apply this basic concept, and it could be positively charged also. Not always. Keep in mind, all the positively charged species need not be electrophile, right?
Yes, sir.
Generally, they are electrophile. For example, I'll tell an exception. Neutral. This is very important because this is going to be our main electrophile in class 12. So rule here is if there is a difference of electronegativity between two atoms, the less electronegative element is electrophilic center. Less electronegative element, electrophilic center. Note down this point.
Yes, sir.
Then example. For example, CH3Cl and CH3CHO. To draw this structure, and I'll draw for you because time is less. Only 10 minutes there, and I have to complete the topic. So now I'll not be giving you much problem to practice. In next class, I'll give you. Very soon I am going to transfer in the batch, right? So, but before I transfer you in the batch, I should be assured and okay, that you will be comfortable with the batch, right? So I have to take few more extra classes. So CH3Cl. So this is the bonding pattern. I talk not electrophile. I say that, or we say electrophilic center. Entire molecule is not electrophile. There is a center. There is a atom. You see here CH3Cl. You see the difference in electronegativity. Which is more electronegative, carbon or chlorine? Tell me. Carbon. Electronegativity you have forgotten. Say these are fluorine, oxygen, nitrogen, and chlorine. These are phone call. F1 phone call. You can remember like that. Phone call. Okay. So it are most electronegative element. These are most electronegative element. So chlorine is fourth most electronegative element. Although its electronegativity value is similar to nitrogen, but you can say it is fourth. The reason for that. So it is more electronegative element. It has negative charge. It has positive charge. It is electrophilic center. Right? Similarly, CH3CHO. When I draw the structure, again oxygen number 2. So carbon and oxygen bond is there. You should have, and carbon and hydrogen are almost equally electronegative. So don't talk much about carbon hydrogen. So between carbon and oxygen, which is more electronegative?
Oxygen.
Oxygen. It is a negative charge, it is a positive charge. This is electrophilic center. The neutral species could also be electrophilic center. Hold on, please. Right? Next is I write down. Positively charged species are generally, here second was positively charged species. Generally electrophile. These are generally electrophile. Not always. For example, if you see H plus, say suppose Ag plus, suppose you find CS3 plus, okay, or Br plus, etc. So naturally it has positive charge, so it is electron division. But exceptions, that is more important. Nitrogen and oxygen with positive charge, not electron division. See, I'm just going to draw the structure. You will find their octet is complete. NH4 plus. We have studied about NH4 plus. Now tell me how many bond it will have. Positive charge. 4 bond. Lone pair. Its octet is complete. Octet of nitrogen is complete. So it is not electron division. It is not electron deficient. 4 bond, 1, 2, 3, 4, 8 electron. How can you call it electron deficient? So generally positively charged species is electrophile, but if nitrogen has positive charge, oxygen has positive charge, you will not call. Similarly, group 1, group 2, but I'm not going to give you all the things because you'll get confused. Just keep in mind generally positively charged electrophile, but nitrogen, oxygen not. Hold on, please. Done. Okay, whenever you finish, now type D in the chat box. So in class we have this coding. Done, D. Or if you want to stop me from wiping, W, wait, right? So you can type D or W, depending upon what you want me to do. So that's all for today, right? So